Okay, today is Wednesday, January 27th, and before we start our math lesson, we're going to go over our warm-up, which was on page 98 in our Star Master book. So those of you at home, you can pause this video and work these problems out on page 98 before you listen to the remainder of this video, okay? Number 1 says, look at the objects below. What attribute do they share? So what attribute do y'all see that they have in common?
They're both straight. But they all,
well, they're not straight. They have curved surfaces.
You can take out full faces and two vertices because they are round, they don't have vertices, and they don't have full faces.
Okay, very good, Allie. Allie said we can take out or eliminate two vertices because they don't have vertices, and four faces because they only have how many? Two. Good. The top and the bottom. Okay, so two faces. Four angles.
No.
Okay, angles are for 2D shapes, not 3D. Okay, so we don't see any angles.
Two bases.
Two bases. Well, bases is the same as kind of a face, but a base we consider something it can set on, okay, or sit on. Okay, so this is a base because we can set the can or the cylinder on it. And if I flipped it over, could this be a base also?
Yes.
Yes. So these are your bases. So A is correct. They both have two bases. So a base is just another word for bottom, the bottom of it that you can set on a table or a flat surface. Okay, number 2, look at this TP made for a class project. Which shape does this TP best represent? We have a cone, we have a square pyramid, a triangle, a triangular prism. Which ones do we know are obviously wrong? Javea? B, C, and D? Is that what she said? Okay, so all of them but A. Square pyramid, I mean, it would look like a triangle face, but the bottom or the base is going to be a square. Okay? The triangle, that's just going to be 2D, that's not 3D. In a triangular prism, y'all remember what that looks like? Kind of like a tent. To me, it looks kind of like a tent or the roof of a house.
That's a tent.
Okay? Triangular prism, but this has rectangles for part of the faces. See, this is a rectangle right here. Does this have any rectangles? Does a TP have rectangles? No, it's curved all the way around. Okay? So that would be A, a cone. Okay, good. 3. Carlos used this ball in PE class. Which shape does a basketball best represent? Circle?
No.
No, circle is 2D. This is 3D shape. A cube?
No.
No. Cylinder?
No.
Sphere?
Yes.
Yes. Good. And number 4, which three-dimensional shape has 5 vertices, 5 faces, and 8 edges? Okay, well let's just start with a cube. We know a cube is like a dice. And a dice has how many numbers on it? 6, because the highest number on a dice, if you roll a dice, is going to be a 6. So that has 6 faces. So it cannot be a cube because we need 5 faces. What about a sphere?
No.
No, a sphere has how many faces? 0. Square pyramid?
Yes.
It's possible. So let's come back to that one. Triangular prism?
No.
Triangular prism, remember, looks like this guy down here, the tent.
No.
And a square pyramid looks like this one. So let's count.
It has 5 faces.
Okay, so that's as good as I can do on a square pyramid. So let's count the faces. 1, I'm going to count the bottom first, so that's 1. And now the sides. The front is 2, the right is 3, the back is 4, and the left is 5. So far we're good. Now let's count the vertices. Where do I count vertices? Bryson? Where the lines meet. Good. So 1, 2, 3, 4, 5. So it still is good. Let's try edges. So what would I do to count edges? Kelsey?
You would count the lines.
Count the lines. 1, 2, 3, 4, 5, 6, 7, 8. 8 edges. So it had all of these.
So the answer is triangular pyramid.
C.
I knew it was square pyramid because it's right up there.
We can do the triangular prism too, just to be sure. Because those are the sides that you wouldn't be able to see, so that's why I put dots. Because it's a solid figure, you wouldn't be able to see through to the other side. Okay, so let's count the faces. The front and the back would be 1 and 2, left and right 3 and 4, and the bottom is 5. So 5 faces. Vertices. 1, 2, 3, 4, 5, 6. So can it be the triangular prism? No, we needed 5 vertices. Okay, so C was the correct answer. Okay, all right, now you can put your warm-up away. We are going to open our Go Math books now to page 55. So volume 1. Everybody got your books?
Yes.
Okay. So those of you at home, if you need time to go get your book, just pause and start back up. Okay? We are on page 55. Okay, we're going to read at the top. Today's goal is to represent and locate fractions on a number line. Okay, but real quick, let's review. Who can tell me what a denominator is?
Ooh.
Evangeline, what's a denominator?
It's the bottom number.
Good. So this is your denominator on the bottom, and the denominator represents the what?
Oh.
The total. Good. Okay. What is this number on top called?
Cough.
The cough. What?
No, the compose. Something.
No. You're thinking of compose, but no. We have a denominator that goes on the bottom,
Compost.
numerator that goes on top.
May I read the question?
Okay? Compose means to put together, so we add them. Decompose means to break it apart. Okay? That's what we went over yesterday, but today we're going to be looking at number lines. Okay, who wants to read the Unlock the Problem for me? Okay, Allie?
Billy's family is traveling from his house to his grandma's house. They stop at gas stations. When they are 1/4 and 3/4 of the way there, how can he represent those distances on the number line? You can use the number line to show fractions. The length from one whole number to the next whole number represents one whole. The line can be divided into any number of equal parts or lengths.
Okay. So today when you're looking at number lines in the book, they're going to already basically have it labeled for you, okay? But there are some times where you're going to have to figure it out. You're going to have to label it on your own. We're going to practice that later. But first, let's look at the one that they already have labeled. They've already started it for you down here. What do you notice the number line starts with?
0
Kelsey?
and 4.
0. 0/4. Okay, so your number line is always going to start with 0, okay? And how did they get the denominator 4? Bryson?
Because that's how many boxes there are.
That's how many boxes there are? Good. And that's what they're talking about in the problem, right? Fourths. Okay, so the line is broken up into 4 equal parts. Okay, so here's one part. I'll trace around this box. That's 1/4. Okay, so this whole piece from 0 to the next box would be 1/4. Put it up and pay attention. Okay, so now go ahead and put a little mark here above the next blue box. From here to the next line would be what?
2/4.
2/4. Good, Allie. So 2 is your numerator, 4 is your denominator. Okay, and now we have another blue box. So the distance from here to here is 3/4. Okay, and then one more piece would equal the whole thing, 4/4. Okay, so when you get to the end, your denominator and your numerator should be the same because that equals 1 whole. Anytime your numerator and denominator are the same, that equals 1 whole. Okay? So because it was talking about fourths, we divided the line into 4 equal parts. And we label each part starting with 0, and you're just counting in order. Pretty easy, right? 0, 1, 2, 3, 4, stopping at 4. Okay? Okay, let's flip the page. Page 56. Example 1. Complete the number line to name the point. So everybody see this point down here? We're trying to name the fraction that point is on, okay? They've already broken the number line and given us the denominator, okay? The reason the denominator is 6 is because they've broken the number line into 6 equal parts. So how much is one part going to equal?
2.
Bryson?
1 part is going to equal
1/6. Good. So when you say 6, remember it has a TH on the end of it. Okay. So at the beginning of our number line, we always start with 0. So what do you think comes next on the number line? 1/6. 2/6. 3/6. 4/6. 5/6. And notice at the end, what do you notice here? What do you notice about this fraction at the end, Evangeline? It's 1 whole because the numerator and denominator are the same. Six is the whole number line, all of it. Okay. Shade the fraction strip diagram to show the location of the point. Okay, so they want us to shade. Okay, so that's 1/6, 2/6, 3/6, 4, 6, and 5, 6 that we shaded in. 5 parts.
So now there's 1, 6.
So there are
1, 6.
5 out of 6 equal length shaded. So that names the point as 5, 6. Make sense? Thumbs up if you're understanding. We're ready to move on. Okay, good. Now this number line down here, let's look at number 1. It says use fraction strips to complete, which is just the boxes above it, and draw a point to show 2/3. Okay, so if this is split into 3 equal parts, so let's show you how it's split. I have 1 part here, 2 and 3. If there's 3 parts, then my denominator becomes 3. Okay, so the denominator is how many total parts there are on the number line. In this case, there are 1, 2, 3. Okay? So what comes next? What would be this part?
1, 2,
2/3. Good. So we're going to label our fraction strip up here. And the next point on the line would be 2/3.
3/3.
Okay.
3/4.
I draw another fraction strip. And good. This is at the end. After 2 comes 3. So it would be 3/3. Okay. So if I shade in my fraction strips, I want to draw a point to show 2/3. There's 1/3, 2/3. So where would my point need to be drawn? Right above where we wrote 2/3, right? Okay. Okay, number 2. This time, the number line is split into how many pieces without even counting?
1, 8.
And 3.
8. Good. I know it's cut into 8 equal pieces because the denominator is 8. Okay? So now, let's figure out what point A should be. I want you guys to try that and raise your hand when you have your answer. Point A. What fraction would go there? Bryson has an answer. Devea has an answer. Okay. What'd you get, Devea? 3/8. Y'all agree?
Yes.
Okay, good. Good, because that's 1, 2, 3. Okay, point B.
2.
Mm,
Wait, no.
Point 7.
Bryson, what'd you get?
6.
Okay, he says 6/8. So let's see. We had 0, 1, 2, 3 8s, 4 8s, 5 8s, 6 8s.
And then C is 7.
Okay, so yes, after 6 would come 7. So it just changes on the top. The denominator still stays an 8. Okay?
I didn't go
Okay, let's skip number 5.
Can I read it?
Go on to number 6. Write the missing fractions for the number line. I want you guys to try that on your own. Shouldn't take you but a few seconds. Label that number line. Let's check your answers. So, even if it didn't give me the bottom number right here, which is 4, a way we can figure out is by looking at how many pieces they cut the number line into. So I want you to take your pencil and we're going to practice counting pieces or spaces on the number line, okay? So from this line to the next line, how many spaces is that?
2.
No, just one space. From here to here is 2. 3 spaces, 4 spaces. So since I counted 4 equal spaces or 4 parts, then your denominator becomes 4. Yes, but in a minute we're going to look at number lines where the denominator is not given to you. So since there's 4 spaces on the number line, then that number becomes your denominator. Okay? So at the beginning you should have put 0 fourths. And then 1/4, 2/4, 3/4, and 4/4. Okay? Any questions on that?
No.
All right.
There's nothing to read.
Everybody there? Okay, let's skip down to number 9. Number 9. Kind of skipping around based on what we need to work on. All right, Bryson, go ahead and read.
John uses 1 tank of gas to make 6 trips to his brother's house. How many trips can he make on 2/6 of a tank of gas?
Okay, so let's draw our own little number line. Okay, and what do you think my denominator is going to be on this one? What would my denominator be? Just call it out. 6, good. Okay, now I want you to try to break up your number line into 6 equal parts, okay? If you want, you could start in the middle, okay, and then cut it like that. Okay, so you should end up having 6 equal spaces. Okay, so we got it broken up into 6 equal parts. So 0 would be at the front. This would be 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. And this is representing the whole tank of gas. So when you get to the end, you're using the whole tank of gas. Okay, y'all have that labeled? Okay, so John uses 1 tank of gas to make 6 trips to his brother's house. How many trips can he make on 2/6 of a tank of gas? Okay, so he goes from 0 to 1/6 to 2/6. And in that whole tank of gas, he makes 6 trips. So if he just goes to 2/6, he's not making 6 trips. He's making how many trips? Somebody said it. 2. Good. I know it's kind of confusing how they worded it. But what they're saying is if he's going to make 6 trips on a whole tank. So here's 1 trip, 2 trips, 3 trips, 4 trips, 5 trips, 6 trips. Okay? But if he only has 2/6 of a tank, he can't make 6 trips, right? Okay? So he's going to go 1 trip, and 2 trips because he has to stop at 2/6, right? So he can make 2 trips on 2/6 a tank of gas. Okay. Number 10. Which fraction names point F on the number line? Which fraction names point F? B? Raise your hand if you think it's B. Somebody said B. 2/6. Good, because it would be 0, 1, and point F is here, so after 1 comes 2. Okay? Alright. Let's go ahead and close our books, and now we're just going to practice looking at number lines without the denominator. So I want you to just close your books and get ready to listen and participate by answering some questions out loud. Okay, so now we are looking at some open number lines. By open, I mean there's nothing on it except the beginning and the end. So we need to figure out the denominator, and some people in class have already told me what they think they need to do to find the denominator. So who can tell me again, what are we going to do on this first one to figure out what our denominator should be? Evangeline? Count the spaces. And why don't we want to count the lines?
Because sometimes we'll count the first one as a line.
Good. I want y'all to get in the habit of saying spaces instead of lines, because sometimes people like to count the beginning. So if we did that, we would say 1, 2, 3, and that's not right. So if I count the spaces, there's 1, 2. So what would my denominator be?
2.
2. So this is going to be 0 halves. What would come here?
1/2.
1/2. And this is 1 whole, or you could also put 2 halves. Because they're equal, right? 2 halves equals 1 whole. Any questions on that? Does that make sense? Okay. Now let's go to the next one. So let's count the spaces. 1, 2, 3. So what is my denominator? 3. So this would be 0 thirds. What would come here?
1/3.
1/3.
2/3.
2/3.
3/3.
3/3, which is the same as 1 whole. Okay, who wants to come up and do the next one? All right, Kelsey.
This one?
Uh-huh.
1/3, 2/3, 3/3,
Oh, count your
4/3.
spaces. How many spaces did you count?
4/3.
Just 4 spaces. So what would your denominator be?
4.
4.
0 4th,
Good.
1/4, 2/4,
4
3/4.
3/4. Good. Okay, good. So that's your number line. You labeled it correctly. She counted the spaces. That tells me the denominator must be 4. All right, Allie. Only 2 more left, and then you guys are going to practice this on your own.
1, 2, 3, 4, 5. Oh, wrong one.
No, it's okay. Keep going.
6.
Okay.
There's 6.
6 spaces. Good.
6 spaces. Then there's one of these. 0. third,
Not third.
third, 6,
6. There you go.
one six, 2 6, 3 6, 4 6, 5 6, and 6 6.
Okay, good job. Okay, last one. Angeline.
One, 2, 3, 4, 5.
Okay, good job. Any questions on that, guys?
No.
All right, so your assignment is going to look like this in Seesaw. Oh, not that. Okay. The star is what you need to write the fraction for on the line down here. The line is kind of hard to see, but this is where I want to look and find your answer. Okay? So you need to count the spaces just like we practiced. There was 3 spaces on this one, so the denominator becomes 3. Then you label the number line, and then your final answer is whatever the star is on. So what would my answer be here? 1/3. So in the middle of each box, I should see your answer for where the star is. Got it?
Got it.
All right.